Welcome guys. In this video we are going to see some example how to apply this Kirchhoff law in a circuit. In the previous video, actually in the lecture 1 we learned all the laws and all the terminologies and how to apply it. And in this video we are going to see some example so that we can understand how to apply it in a problem. So this is the lecture 2 of Kirchhoff law and its application. So in the first example, the circuit is given here. The R1 is 5 ohm, R2 is 3 ohm, R3 is 2 ohm. Say this is V1 12 volt and V2 is 6 volt, and the direction of current is given in the question. It is given that I1 is in that direction, I2 is in this direction, and I3 is in this direction, and I2 is in this direction. We want to calculate I1, value of I1, I2 and I3. So first step is point out the node. So here there is two node in the system. It is the N1 node or junction. There is two node in our system, and there is two branch. This side one branch and this side one. Then draw your loop in the branch. Here we take the direction of loop in this direction. The direction of choosing the direction of loop is completely arbitrary. Here we choose the direction of loop in the same direction. So for now in the junction or node N1, let us apply Kirchhoff current law. So in the N1, I1 current is coming, so that's why we are taking it as positive. I2 current is leaving, I3 current is leaving, that's why they are negative. So total sum is 0, which is implying I1 equal to I2 plus I3. Then came to another node N2. In that N2, I3 is coming in the node. This is I3 is coming in the node, that's why it is positive. Where I2 also coming in the node, it is positive, but I1 is leaving the node, it is negative. So their total sum is have to be 0 based on the Kirchhoff current law. Actually Kirchhoff current law provides us the conservation of total charge. So again from here also we are getting I1 is equal to I2 plus I3. So take both the equation same. So now let us label I1 is equal to I2 plus I3 as equation 1. Now let us apply Kirchhoff voltage law in the loop 1, and we will move in clockwise direction. We choose it completely arbitrary. We can even go around anti-clockwise direction also. So we are going to move in this direction. First we encounter. So start from here. We are encounter this R2 resistance. The voltage drop across this resistance will be 3 into I2, but we are going in the direction opposite to the current. That's why we have to take the voltage as a negative. So the voltage drop will be minus 3 I2. Now came here. We are near to R3. Now voltage drop across R3 will be 2 ohm into I3, 2 I3. In that case we are going in the direction of I3. Direction of I3 is in that direction. So we are also going in the same direction in our loop. So we will take that voltage as a positive. It will be plus 2 I3. Now we reach here near the battery. Now we first see the negative side of the battery. So we will take minus 6 volt, and the sum of all these voltage will be 0 according to Kirchhoff voltage law. So from here we are getting 2 I3 minus 3 I2 is equal to 6 volt. This is our equation 2. Now applying Kirchhoff voltage law in the loop 2. In the loop 2, we are going in the clockwise direction. Let us start from here, or we can start from here also. So if we start from here, we are going in the direction opposite to the direction of current. Current is going in this direction. So our first term will be voltage drop across R1 will be 5 R1, but we have to give 5 I1. Voltage drop across R1 will be 5 I1. We have to give a minus sign. Now we are here. When we are going, now we arrive at the positive side of the battery. Now we see first positive side of the battery. Now we will take plus 12 volt. Now we are going up. So now we have to consider the voltage drop across R3, that will be 2 into I3, but in that case we are going in the opposite direction of current. So we will take minus 2 I3. So according to KVL, sum of all these three will be 0. So this is giving us another equation, that 5 I1 plus 2 I3 equal to 12. Now we have to solve. We have three variables, I1, I2 plus I3. I1, I2, I3. Now we have three equations, equation 1, 2 and 3. Now we can easily solve. Now from 1 and 3. So here instead of value of I1, we are putting I2 plus I3. Now equation coming out to be 5 I2 plus 7 I3 equal to 12. Now let us say it is equation 4. Now multiply 5 with equation 2. So multiply 5 with this equation. So that is coming out to be, so minus 15 I2 plus 10 I3 equal to 30. And now multiply 3 with equation 4. So it is coming out to be 15 I2 plus 21 I3 plus 36. So now just adding these two equations, we are getting I3 as a 2.13 ampere. Now we get the value of I3. Now put it back to equation 2. So in this equation again, so 2I3 minus 3I2 equal to 6. So put the value of I3. It will give me that I2 will be minus 0.58 ampere or 580 milliampere. In this case, actually minus sign indicating that there is no wrong in our calculation, but the direction of the current given in the question is wrong. Now from equation 1, we can easily calculate the value of I1. We know the value of I2 and value of I3. Just putting the value of this I2 and I3, we are getting the value of I1 as a 1.549 ampere. So this is the final value. So in the picture, we have to just readjust our picture a little bit. In the actual problem, our direction of the current was in that direction, but we have to just change the direction of I2. So we show how to apply a Kirchhoff's law to get the current. We can see a simulation of this problem, which will give us a better idea. So here this circuit is actually same circuit of our problem. So we can see our I1 is going. I1 is 1.55 ampere and the direction of current is given here. In around 5, above the 5 ohm, the direction of current is given. This side, in the middle, this is our R3 current or I3 here also 2.13 ampere. The direction of current is given, as well as came to our resistance 1 and also I1. I1 is given 0.581 ampere or 581 milliampere. So our calculation is right. Now came to our example 2. in this example, the direction of current is given, that I1, I2, I3 is given. We have to find out here also value of those current I1, I2 and I3. Find out those value. Now we choose our nodes here, N1 and N2. These are my nodes, and then we also choose my loop L1, which is clockwise direction, and loop L2, which is anti-clockwise direction. That choosing of the direction of loop is arbitrary. There will be no problem. The direction of current is here given. Now if we apply the KCL at loop here node 1, at this node 1, this I2 is coming, I3 is going into the battery, so same I3 have to be came out, I3 also coming here, so I2 plus I3 are positive, but I1 is leaving the node, so the value of sign of I1 will be minus, so sum of this will be 0. Then we can say I1 will equal to I2 plus I3. Now came to the node 2 here. At this node, I3 is leaving the node, I1 is coming the node, and I2 is also leaving the node. So I1 is coming, I2 leaving, I3 leaving. Sum of all those have to be 0. So I1 equal to I2 plus I3. So this equation of current at these two nodes are same. So we can say we are lucky here. So I1 equal to I2 plus I3 is our equation number 1. Now apply Kirchhoff voltage law KVL in loop 1. That means upper loop. Let us start from here. We can start from anywhere in between the loop. There will be no problem. Every time answer will be the same. So now in this case, the voltage drop across 25 ohm will be, current passing through the 25 ohm is I1. So voltage drop across 25 ohm will be 25 I1. Here we are going in the direction of current. So our voltage will be positive. Then we are coming, then we reach the negative side of the battery. Then we will take minus 45 volt. Now before completing the loop, we reach here. The voltage drop across the 30 ohm will be 30 into I2. In that case, we are going with the current. That's why we have to take the voltage drop again positive, plus 30 I2. So this is our equation. Now just little bit mathematics will give it a simpler form. 5 I1 plus 6 I2 equal to 9. So indicate is as equation 2. Now let us apply Kirchhoff voltage law in loop 2. So let us start it from here. So the current through 15 ohm is in this direction, I3. So voltage drop across 15 ohm will be 15 I3. Since we go with the direction of current, so it will be positive. Then we reach at the positive side of the battery, we will take plus 75. Now when we reach here, we are in the opposite direction of the current I2. Voltage drop across 30 ohm will be 30 I2. That sign will be minus 30 I2. Again we reach here, plus side of the 45 volt. So the voltage will be added as a plus sign. So to sum of this total will be 0 according to KVL. So again, small mathematical calculation give us this simple equation. Now we have 3 variable I1, I2, I3, 3 unknown, and we have 3 equations. So now let us use the equation 1, that means I1 is equal to I2 plus I3, and put it into equation 2. In the place of I1, put it this equation. So this will give us 11i2 plus 5i3 equal to 9. So call it equation 4. Now let us try to solve equation 3 and equation 4. Multiply equation 4 with 3 and equation 3 with 5. Give us these two sets of equation. Now subtract these two equations. When we will subtract, these two terms cancel out. So now we will get 63i2 equal to 147. It will give us a value of i2 as 2.33 ampere. That means direction of i2 is okay. The given direction of i2 in the problem is right. Now from 3, if we put the value of i3 back here, it will give us the value of i2. So we are putting the value of i2 here. It is giving us the value of i3 as a minus 3.33 ampere. Now let us use the equation 1, that is i1 is equal to i2 plus i3. So it will give us i1 as a minus 1 ampere. That means our current will be i1 will be 1 ampere, i2 will be 2.33 ampere and i3 will be 3.33 ampere. The thing is that the direction of i1, we have to change the direction of i1 and i3. The direction of i1 will be in this direction and direction of i3 this will be in this direction. So this is the change we have to make. Again, let us see the simulation in this case so that we can get the idea about that. So let me move. Yeah, this is the circuit in our example 2. So we can see it on 25 ohm current, 1 ampere current is going. The direction of current is in the direction given, direction of arrow is given. We can also see current through 30 ohm is 2.33, that is our i2, and i3 is 3.33 ampere and direction of current is also given. So that is the problem we did is right. Okay, thanks for watching. The PDF copy of that blackboard, link of the PDF copy will be given in the description, as well as the link of the previous video will be given in the description. If you like the video, share and subscribe.